Hey there, Math 2403. Welcome back. Still working on Unit 1. This is the fifth and final video of Unit 1. Today we're going to talk about abuses of statistics. It's kind of a fun topic, one of my favorites. Uh, it's one of those things where we want to talk about abuses of statistics for two reasons. We want to talk about them so that we avoid making mistakes and abuse statistics inadvertently. And we also want to know when we're being fooled. So it's kind of an interesting topic. We often get bombarded by data these days. So let's just dive right in. Yeah, here we are, abuses of statistics. Um, Ideally, or we hope that most abuses of statistics are just due to carelessness. People make mistakes. They don't really have a good background and they're jumping to conclusions or making poor graphs because they just don't have the background. Uh, this is something that, obviously can happen. Almost every university and, college student has to take statistics course. So we all know a little bit, and maybe sometimes that's dangerous. Although, honestly, I think that over the years, since most programs have added statistics courses to their programs, that statistics out in the media have gotten better, in my experience, uh, than they used to be. I think there used to be a lot more bad stats. So that's good. The other way we make mistakes is on purpose. We have some sort of agenda, personal objective. We're trying to show something, and we manipulate the data so that is it gets our point across. I made a little list of some ways that stats can go wrong. This isn't comprehensive. It was just basically what I could come up with off the top of my head. Uh, and we'll do like little examples of each one of these, bad samples, distorted percentages, partial pictures, deliberate distortions, loaded questions, misleading graphs, pictographs, and precise numbers. In the past, I have asked students to evaluate bad graphs. So sometimes on a midterm, there'll just be maybe a newspaper headline and with an associated uh, graph of some sort, and I'll ask the students to sort of, comment on it. You know, it's a sort of a weird open-ended question where it just basically says, "Here's here's a newspaper article. Explain." Or what do you think about this? And use statistical terms in your evaluation. And usually it's something that isn't very good, so that there are things that you can pick apart. So hopefully you'll learn some of that in this lecture today. The number one abuse of statistics is a bad sample. Now, oftentimes samples are just too small. They don't represent the population. We jump to conclusions based on a small set of data. And this happens because it's expensive to get good data. It's hard to conduct studies. It's hard to get people to participate in studies. So unless it's some sort of controlled experiment where it doesn't involve people, the is data involving people is very difficult, I should say. You hear a lot of election polls don't always predict the outcome of the election that well in recent years. And that's because we're talking about people, and people are very unpredictable. So when you see some sort of statistics being presented, one of the first questions you should have is, how big is this sample and how did they get it? Those two questions need to be answered before you can begin to believe the results of the study. I have some exaggerated examples in here, you know, uh, just mostly to make fun of this. But if I ask what percentage of BCIT students are female, and I look at, an engineering class versus a nursing class, that's those samples would probably not be the best way to evaluate uh, how many students on campus are female. Again, it's a kind of exaggerated. Nobody would go to that extreme, but you get what I'm going for here. You want to make sure you'd represent BCIT well, so you wouldn't want to just maybe even look at day school students. You'd have to, consider the part-time and the night school. Uh, Other biases that we have in samples are self-selected surveys. Those are, you see these on the news. You'll see people, or the news will say, we're going to have a story tonight about increasing the speed limit in school zones. What do you think about this? Go to our website and tell us how you feel. And then at the end of the, 20 minutes later, they'll get to that report and they'll add the results of, what people's opinions were about the topic. And you have to really be cautious about self-selected surveys because, think about who is going to bother to reply to that survey. Who's going to bother to log in and voice their opinion? It probably is just the people strongly against it. It's unlikely that the other people would be very well represented. So you get kind of skewed results. Uh, so yeah, watch out for those. This one's kind of interesting. Flawed samples. In a study done of occupation versus age of death, they draw a conclusion that students die at an early age. So this, this seems preposterous, but if you looked at the data, you might see that the average age of death of a student is 20 years old. And the average age of death of a teacher is 78 years old. And the average age of death of a logger is, 68 years old. And the average age of death of a coal miner is 65 years old. But when you look at those numbers, you might say, well, I guess students, since they die when they're 20, that's a very dangerous profession to be a student, where we all know that the reason the average age of death of students is that low is most students are young. So if they were to die, they were died at a young age. So this would be a terrible conclusion to draw from that sample data. Other interesting things, maybe moving on from sampling, would be distorted percentages. We have two newspaper headlines. The first one says, average property taxes in Vancouver have increased by 100. In the rural areas, they're only up by $40. Vancouver residents screwed again. That was the Vancouver paper. But then you go into the interior a little bit and you go to the Keremeos Echo newspaper, and their headline says property tax in Keremeos is up by 10%. In Vancouver, up by only 5. Why should we pay more? So this was the same day. Completely different headlines. And they're both actually right. If you have property tax of 10% in Keremeos, then their tax went up by $40. If your taxes go up by 5% in Vancouver, well, your taxes have gone up by $100. So it's actually right. Keremeos, it went up by 10%. Vancouver, it went up by 5%. So it's crazy that you could have two ways of selling newspapers or subscriptions to their online, you know, news just by spinning it. In this case, I think the percentages are probably better or more representative than by going with the raw values, especially if the raw values don't also include what property taxes were in those two jurisdictions. Here's one I heard on TV the other day during a football game. There was a commercial. 90% of all cars sold in the country in the last 10 years are still on the road. And they're trying to tell us that that's a sign that their cars have quality. Of course, maybe, you know, think of a car company that's newer, somebody like Tesla. Certainly, their cars sold in the last 10 years are still on the road because 10 years ago, maybe they didn't have any cars. And 8 years ago, they sold 1,000 cars. But last year, they sold 3 million. Well, certainly their cars are still on the road because almost all of their cars were made last year. So you have to watch out for, sneaky little tricks like that. If, if the Toyota Corolla made this claim, it's a reasonable claim. They probably have been making those things for 10 years, and it's reasonable to judge them this way. Sales are probably similar from year to year. But if you don't know the distribution of sales within the 10 years, it makes that kind of a sneaky question or statement. Deliberate distortions, the example here is okay, but again, I was watching football and every single commercial seems to be a commercial for trucks. And every truck is the best truck. You got Ford truck, best truck in Canada. Mazda truck, best truck in Canada. Toyota, strongest truck in Canada. Everyone is the best truck. No data to support these things. They just seem to make it up. Or sometimes they'll get a magazine that will support them. They'll say, oh, according to some magazine, Ford truck beds are the toughest beds around, and Chevy trucks can tow the most. But you've never heard of anybody be the number 2 truck. No data at all. Sometimes when we're looking at data, it's collected via a survey, and the questions are bad. When I get a call, I still have a home phone. If I get a phone call to do a poll, I used to hang up on them. But now I like to answer them primarily because I consider it part of my job. I want to know how they're asking their questions because sometimes they load them. These polls are often done by these independent research companies that are very well respected. However, someone is paying them to do the poll and will often contribute the questions that they want asked. And that's why you can't just say, oh, I saw an Ipsos Reid poll and necessarily believe the result. Yes, Ipsos Reid may have done a great job of collecting the data, but we don't know necessarily exactly how the questions were worded. Do you contribute to charity every month versus how often do you contribute to charity? Those two things are pretty subtle, but one of them kind of implies that you should be giving to charity every month versus the second one where it's more open. So one might encourage you to essentially lie. Some really crazy ones here. Do you support the development of atomic weapons that could kill millions of innocent people? Who's going to answer yes to that? Of course, we could leave out the killing millions of innocent people and ask if someone supports development of atomic weapons. And you might get some people to say yes to that. Maybe in the development of them, they come up with some, new power source. We may not have nuclear power plants if it weren't for atomic weapons. So it's possible that some people might answer yes. But if you add that could kill millions of innocent people, I think we're uh, losing that question. Uh, Sometimes the question isn't intended to be loaded, and this is really a weird question. I'll read it out. Would you say that traffic contributes more or less to pollution than industry? Versus, would you say that industry contributes more or less to pollution than traffic? Same question. It's just the order. One lists traffic as the problem first, and the other one lists industry first. In a long, boring question like this, I don't know, as a student, I know occasionally I got called on in class and I wasn't paying attention and I'd try to replay what they were saying. And I don't know what they said, but the last thing I heard was traffic. So I might answer traffic to this one. Or maybe you're the type of person that pays attention for a while and then zones out. So then you might be a person that answers industry because you can't remember the rest of the question. Uh, so sometimes just the word order can make a difference. And these two questions are terrible. I'm not even sure what you're supposed to say because it adds more or less. Like if you say yes, what are you saying yes to? If you say traffic, what are you saying? Is it more or is it less? So I think every answer might be correct in this situation. Uh, yeah, terrible question. I think lawyers do this. They ask long questions to try to trip up the person they have on the stand, or they're doing some sort of investigation on. Even police too. Uh, if you ask somebody a long enough question and then you force them to answer yes or no at the end, maybe part of the question you would agree with, but another part you would disagree with, and then you get forced into a situation of answering yes or no. It's really uh, sneaky. Bad graphs, these are my favorites. Uh, every time I see any graph anywhere, I try to tear it apart. Here are some examples. The premier of our province was giving a speech a few years back now, and it was near an election time. And during the speech, you know, if you watched it on TV or YouTube or whatever, this graph popped up beside, and they used this graph to basically explain that British Columbia is doing great, and as such, you should continue to keep us in power because we're doing such a good job for you. So I saw that on TV and was like, wow, that's interesting. You have BC, what is it? What's it talking about? It says income tax. So you don't have to pay much income tax if you're in BC. But if you're in Quebec, you pay a lot. That is if you're someone who makes $45,000 a year. But if you look at this graph, you'll notice that there is no scale. So when you first glance at it, it looks like Quebec is, paying like 7 times the income tax that someone in BC is paying. And you'll notice that they also put these provinces in order to make it sort of look like it's trending up, but we're doing the best. I thought that was kind of sneaky too. Like they didn't put them in alphabetical order or geographical order. They put them in sort of from smallest to largest. The question is there a big difference between the BC income tax and the Quebec income tax? And when somebody fact checked them, it was like $100 difference between these two values. So really, the provinces were roughly all the same. They just zoomed in so close that they made it look like BC isn't paying any income tax. Another interesting thing was they didn't show any other income levels. Like they just picked this one to show us. So what if you make 70,000 or what if you make 30,000? Is BC good in that case? Maybe not. So they only picked the one where they could show BC was really doing well. So that's definitely a bias. Uh, Always look for axes. That is key. If there's no scale, that graph could mean anything. Here's one that's a little less, well, it's probably just as manipulative. Uh, Salaries of people with bachelor's degree versus high school. So your guidance counselor shows you this plot and says, well, you know, if you go on and get your bachelor's degree, you'll make this much money on average. But if you just get your diploma, you'll only make this much money. This is, you can tell this screenshot's from a fairly old book, or maybe it's probably American. So these values aren't so tiny because these are pretty small for Canada, I would think. When you actually look at it, you'll see that the scale starts at 20,000. So it makes it look like the diploma people, the bachelor's degree people make like 5 times as much money, when in reality, if you plot it to scale, you can see, yeah, certainly these guys make more money than these guys, but it isn't nearly, this drastic difference. It's a much smaller difference. So always look at that. Look at the scale. And always look for information about the sample size. In neither of these do we know anything about sample sizes. I mean, presumably in the income tax example, the government knows all the taxes that they receive, so they don't even need to sample. They have the whole province, they basically have the population for data. For this high school one, you might want to ask, which provinces it came from, or, how did they come up with this? Like maybe the difference isn't as big in rural areas as it is in metropolitan areas. So not knowing where the data comes from really can distort things, in addition to that scale. Pictographs, another favorite. Uh, Instead of just giving you a nice bar chart or a nice scatter plot or line chart showing some trend, uh, a lot of times the media loves to give, these pictures to show, try to get you to spend time on it, I guess, kind of a clickbait kind of thing. In this first one, men make this much money, women make this much money. And then the headline says, why do women make so much more money than men? And I don't know what I'm supposed to be comparing. Am I just comparing the heights? Or am I comparing the volume of these cubes, these money cubes? Because if I just double one side of a cube, I increase the volume by a factor of 8. So I'm not sure what the difference between men and women actually is here. Is it 8 times or is it just meant to be double? Same with how do you compare money bags? You know, what is the should I just be comparing height or should I be actually trying to imagine what the volume of these things end up being? So don't use pictograph. Another one is taking advantage of sig figs or a lack thereof. Mean annual salary is $25,532.22. By writing it so precisely, you give your reader sort of the impression that your data is good. Where, yeah, sure, this might be the mean of some sample data, but they may not be able to measure it to the nearest penny. And many other things are like that as well. Uh, so be careful about, being overly precise. Sometimes on our midterms and stuff, I'll ask you for 4 decimal places, even if it doesn't make sense. But that's mostly just so I can just tell if you did the question, the procedure right. Because you could do it wrong, and if you rounded it to the proper sig figs, you might actually get the right answer, particularly when we're talking about probability. When we're talking about probability, we have values between 0 and 1. So if you start rounding things off to the nearest tenth, you could be off by quite a bit from the actual answer. So, yeah. Sometimes you can use uh, your position to kind of influence people. My wife is a master of this. She teaches math as well. When we're at some sort of, social gathering and some topic comes up and people are arguing, my wife will throw out a number, some sort of fact to win the argument. And most people will trust that the number that she threw out is correct because, well, she's the math person. And I've asked her at times, and on the drive home from these places, did you really know that number? She said, no, I was just sick of the conversation. So be careful with that too. I thought we'd do maybe just one more, uh, one from an actual newspaper. The day before I taught this class, for the first time, I picked up a newspaper, and on the front page of the newspaper, this is a USA Today newspaper. I was actually on vacation. I was in Vegas. And this was basically just sitting on the floor of the, they give you free newspapers at hotels sometimes. And I thought, oh, here's my first lecture, the front page. And on the front page, there was this headline, Murder Falls in the Big Cities. And then it had this nice graph made out of police tape. And they said, New York, murder has dropped by 79%. Chicago dropped by 46. LA dropped by 68. Now, I'm immediately suspicious because of one thing for sure. I said, if you don't have a y-axis, are these really proportioned to each other? And are these percentages even correct? The small print says this was between 1990 and 2009. Yeah, I've been teaching the course a long time. In the article, it actually had the raw numbers. So I was able to read through the article and get the raw values. There were 2,245 murders in 1990 in New York, and there were 471 in 2009. So things really got better. And I calculated the difference, and I actually calculated the percentage difference. So I did, B4 divided by the initial total. So 1774 divided by 2245, and sure enough, we have 79% drop. Chicago, their numbers, LA, their numbers. So these numbers are correct if you believe the data. So I wanted to plot this to see if the data is actually to scale. So I can, I highlighted the data. I'm just going to make, your regular bar chart. And I'm going to see if I can get it to match up to theirs. This is how weird I am. This is what I do in my spare time. I check to see if graphs are correct or not. What I can do is, if I right click on the graph and format it, I think I can remove the background of it, the fill. It was set to white. Now I just turned it off. And now you can see that, oh well, they did a pretty good job. So they went through all the trouble of putting that police tape on there, but they didn't bother to put a scale to show me that they were correct. So they made me scan this article in and import it into Excel and do all this rigmarole and bring it to my class, and it was okay. So they didn't actually mess this up. But this USA Today newspaper has kind of a reputation for making bad graphs. If you're ever looking for bad ones, check them out. So, okay, so that ruins the lecture, right? There's really nothing wrong with this. I've discussed this in previous classes, and someone suggested one year that, that's a pretty big drop in those numbers. Is it possible that maybe they changed what the definition of what a homicide was? The difference between 1990 and 2009, we didn't have DNA testing we had limited DNA testing in 1990 compared to 2010. Maybe what they declared murders was different. Maybe they declared a lot more things murder in 1990. And in 2009, maybe they added a category called, suspicious death. And then obviously the murder rate drops because there's some other category that's eating up the numbers. So I thought that was interesting. I had no way to really verify that, but it is, something to think about. Someone else pointed out that they picked New York, Chicago, and LA. Why? Had they included Washington, D.C., or Detroit, or Dallas, Texas, or some other cities, would they show declines, or did they just cherry pick these three cities because that's where the murders were dropping? Which is still interesting, but you can't necessarily say murder is falling in all big cities. The title should maybe read, homicide falling in these big cities, because it may not be a national trend. I did a little bit of research on that. I went to Wikipedia and I was curious to see why they picked those three cities, and it's really killing my argument. The three largest cities in America in that year were New York, LA, and Chicago. And it's kind of nice that they represent the country. You got the East Coast, you got the middle, you got the West Coast. So I think that kind of bursts that bubble, as much as I really wanted to say uh, that they picked those cities just because they were special. They did list the three largest, which does seem to make it kind of fair, and a cross section of the US. I had no idea Houston was so big. That's something interesting from this, that so many Texas cities are so large. Anyway, yeah, so I just found that sort of interesting, uh, that we could just grab something from a newspaper. Maybe we'll do one more. Oh, that one's kind of boring. Here's one. It's kind of fun because it's so old. You know, 2010 newspaper. Who's going to win? This is in the sports section. There's no article or anything. All it had was this chart. Who's going to win the MVP in the NFL? Tom Brady or Michael Vick? It's amazing that Tom Brady is still around. Uh, yes, 10 years ago. I don't think there's anything wrong with the scale. The scale looks okay to me. I mean, we can always make, one and take out that background again. But I think we're going to find that this is fine. Like the scale looks pretty dead on. I'd have to get rid of the color on maybe these as well. I don't know. There, you can kind of see it. But yeah, it's to scale. So they didn't mess with the scale on this one at all. But there is something pretty poor about this. It does say how they got the data. They had voters on the website, which I said generally self-selection is bad, but maybe not so much in this case. From the sports page, you don't really want to poll all Americans to see who's going to win the NFL MVP award. You do want to poll people that are interested in sports. So it makes sense that you'd poll, people that have already visited your sports page. So I'm not too disappointed in the number of votes or how they collected it. But there is something majorly wrong with this. Maybe as I'm blabbing here, you've figured out. Because it turned out, if you want to look it up, Tom Brady did win. Even though he was so far behind according to this poll on, December 29th. It turns out that if you look at this thing, the voters only had a choice between two players. If you allowed them to vote for other players of the 2010 era, maybe Brett Favre would have stolen some votes. Maybe Peyton Manning stole some votes. We have, heck, maybe Randy Moss is still in the league that year. Yes, certainly he was. There were lots of star players who could have cut into their votes. This is like, when you have a third candidate in an election, you have candidate 1 and candidate 2 who are from the major parties, and then you have some third candidate who may steal some of the votes from maybe one of them more so than the other, and that allows the other person to win. So that's sort of what happened here. When given other options, people may not have voted for Michael Vick as much. He had just been convicted of a crime and gotten out of jail and stuff. If you've ever heard the story of Michael Vick. But if you're not interested in American football, then you probably haven't. Anyway, I think that's enough of these examples. They're everywhere, and they are kind of fun to look at. Just pay attention now whenever you see a new graph about how well a vaccine works, or when you see a graph of how some infection rate is increasing or flattening. Take a careful look at those curves and see if they're being presented accurately. That's really what I want to take away from this part. So that's probably enough for now. I will see you all again in unit number 2.